complete the square law. Oh. So, ladies and gentlemen, we have a parabola, or I'm sorry, not a parabola, we have an equation. We want to write it into our standard form, and then we want to plot the asymptotes and make a little sketch of the graph. How's that sound? That sounds fun. Okay, so the first thing is, again, if we know our definition of our parabolas, we need to first, before we can even determine if it's going to be horizontal or vertical, we need to at least be able to see what the graph is going to look like. So first thing we do is I'm going to combine my 4x squared plus 8x minus 3y squared equals a negative 16. So I put the constant on the other side, and I arrange my x's and my y's. And I do that because now I want to make sure that I can combine them, because I forgot to go over this. Let's go over the formulas, right, that we're trying to figure out. Okay, this one is x minus, I don't know, this one would be y minus k. Oh. Okay, so we have our two formulas, and what we need to do is we need to make sure we can write this in that formula, right? So first thing I need to do is now I'm going to have to complete the square. Before I complete the square of the x, I need to make sure I factor out a 4. I can't complete the square with my negative 3, but that's fine. That just means that my k is going to be 0, right? Now I complete the square over here, so I have 8. Got to factor out a 4, so that's a 2. So I have 2 divided by 2 squared, which equals 1. So I have 4 times x squared plus 2x plus 1 minus 3y squared equals negative 16. However, ladies and gentlemen, notice that I'm not adding a 1. I'm adding a 1 that's being multiplied by a 4. So therefore, I'm going to have to add a 4 over here as well. So therefore, now I simplify, or I factor this down to its perfect square, or binomial squared. So it's x plus 1 squared minus 3y squared equals negative 12. Now, again, remember, both of our formulas equal 1, right? Both those formulas equal 1. So let's divide by negative 12. And we'll do this by both terms. Therefore, by simplifying this, I now have a negative 3 times x plus 1 squared plus y squared over 4. I'm sorry, that's a 3 on the bottom, right?
Whoa, so you make the top negative, not the bottom?
It doesn't matter. Negative 4 divided by 2 is the same.
Why are you adding? I thought it was multiplying. Because
the negatives divided by another negative makes a positive, right?
True.
So now, you're right though, this needs to be a subtraction problem, right? So rather than saying a negative number plus a positive, I can rewrite this as y squared over 4 minus x plus 1 squared over 3 equals 1. So you're right. Right? You want to write it in that format, because now when you have it as a subtraction, you know now that a squared equals 4 and b squared equals 3. Right?
How do you, oh, okay.
Because it's always a squared minus b squared for a hyperbola. A squared minus b squared. Huh?
A is always the larger one.
No, not necessarily.
Oh, God.
It's just always in the formula, a squared minus b squared. That's the formula that we're always going to have in this form.
So in hyperbolas, it's not going to matter whether it's bigger or not?
You're not always going to have a larger or a
But
smaller.
I thought you said that the A is
On your ellipse, on the ellipses, that's the way that you're always going to have it. Okay?
So how do you know in here it's the same?
You just write it as a subtraction, one minus the other, and then whatever that is, whatever you're subtracting from, that's your a minus your b.
So it can be negative. It can be 4 minus 5.
Yeah, that was our last example, right? So now let's go and take a look at our h and our k. So if we know our h is now represents our, sorry, let's just do our center. So now I can say the center is going to be negative 1 comma 0. Yes? Yes, no, maybe so. Okay. So, so ladies and gentlemen, if we have our 4 and our y, if our a squared is under our y, now this means we're going to have a vertical one, right?
Vertical.
So, we know our center is at -1, 0. Okay? The vertices are going to be plus or minus 4. So therefore, if a squared equals 4, we know that a equals 2. So to find the vertices, ladies and gentlemen, are your vertices...
Pardon the interruption. Please turn your TV sets to channel 6 for the Mustang News.
Since this has a vertical transverse axis, our vertices are going to be on the transverse axis as well. So our vertices are going to be -1, comma, plus or minus 2, right? Which will be -1, comma, -2, and -1, comma, 2.
Wait, did we ever get formulas to how to figure out the vertices, or how do you figure out the vertices?
It's the same distance, it's a.
Okay.
So it's the same thing as an ellipse, it's just your definition of a. The only thing you need to know is it's on the same as your transverse axis. Remember ellipses, they were all on the same major axis? Well, now they're on the same, what we call a transverse axis. So the h is not changing in this case because you have a vertical transverse axis. The same thing now goes with our foci. Now we need to determine what the foci is. And remember the relationship we have for hyperbolas. Obviously, I think that was a bad reason for you to come back in class at this point in time. Because remember the definition for the foci that we had was c squared equals a squared plus b squared. Well, we have a squared is 4 plus b squared, which is 3. Right?
You just need c squared though, not c, right?
Yeah. Sorry?
Do you only need c squared, not c?
No, we actually need to figure out what c is. Because c is the difference, c is the distance from your center to your foci. So c is the square root of 7, so our foci are going to be -1, comma, plus or minus the square root of 7, which is -1 plus, or sorry, -1, comma, 0. Sorry, 0 plus or minus 2, 0 plus or minus square root of 7. So,
Does that matter?
Yeah, why is it?
Because, yeah, of course it matters. That's a huge mistake. Guys, you're taking your center and adding the vertice to your k, to the k coordinate of your vertice. This one just happened to be c, so it didn't matter.
Yeah, but why do you have to put 0 plus?
No, you don't have to, and that's why I got lazy and I didn't write it. But you need to understand you're adding it to the k form of your center. You just need to make sure you understand that. In this case, yeah, you're going to have square root of 7, and in this case you have -1 minus the square root of 7. Well, guys, you can write those in your decimal form. Square root of 7 is roughly 2.645753. I'm sorry, say that again.
Are you allowed to put negative square root of 7?
As long as you're not taking the square root of -7. But yeah, leave it in that exact answer. So your foci are going to be somewhere right around here. All right. Now, last thing, ladies and gentlemen, remember they're in between. They're between the center and the vertices are your foci. Now, that's an approximate value. The last thing, ladies and gentlemen, we're trying to do is find our asymptotes. So remember, for a vertical asymptote, we have y equals k plus or minus a divided by b times x minus h. So all we're going to do to find our asymptotes is plug in this values. So we have our k, which is 0, plus or minus a over b. So our a is 2, and our b is square root of 3. Times x minus h, which is -1.
You can just leave it as -1. Oh.
So then when I distribute that through, you're going to have that line. Oh, I'm sorry, and it's plus or minus, sorry.
Do we need to do the 3?
We will learn how to graph them, but we'll practice that next class period, just so you guys understand how to find the asymptote, okay? So that's all you guys are really simply doing is plugging them in today.